position, and his current position is Program Manager, Bendable OLEDs. So, looking forward to this. The stage is yours.
Thank you very much for the kind introduction. And welcome to my presentation about basically how the OLEDs advanced and is now ready for the automotive applications. Let's have a brief look at the agenda. First, I will briefly introduce Olledworks to you, a bit of history, and then afterwards we'll talk about especially OLEDs in the automotive lighting space. So key differentiators, where are we today, and where's the journey going towards. So what is in the development pipeline, and what can be seen on the road in the near future. So, Olledworks basically originated from a team which was working at Eastman Kodak with digital photography coming up. Eastman Kodak basically went bankrupt, and the team which worked on OLEDs, part of this team, then founded Olledworks in the US. And then in the same time frame, Philips was working also on the development of organic light emitting diodes for general illumination, but also decided to step out this activity parallel when they sold also Luminets, and that was an opportunity for Olledworks to combine basically the perfect knowledge of the US part with a state-of-the-art manufacturing line which was located in Aachen. So to have all the components and basically those two teams formed even a stronger team. And also we have a sales representative in Shanghai to serve Chinese customers. We are busy in general lighting, specialty lighting, also high brightness micro displays, but today we'll focus on the automotive lighting part, and there we are basically doing taillights, turn indicators, and so on, also chinzels. So, for the ones which are not familiar with OLEDs, I will briefly introduce OLEDs to you. So OLEDs are very thin, less than 1 millimeter. They're surface emitters, and they produce very little heat during their operation. And they give you, or your designers, a lot of flexibility to determine the outer shape and also what is visible inside the OLED logos. And also there's a lot of colors that can be done. So basically OLED panels, they can be custom made and defined to what our customers want. So let's compare especially tail light, LED wise and OLED wise. So for the LED, you have point sources, you then need optics to distribute that, and if you want to have a very uniform light emission of that tail light, you also need to invest quite a lot into your optics. Whereas the OLED is the flat light source, it does not have hot spots, it does not have bright spots, you don't need dedicated heat sink, and basically no optics. So this is basically a simpler, small fixture, fewer parts, and in the end you will be able to save cost. And also, if you compare the same performance of the LED taillight towards the OLED taillight, same specification, deep red, then the OLED module has about 1/3 less power consumption than the LED module. So a rigid OLED, so not bendable but rigid today was on the street today. Let's look at the build-up. Basically, you have 0.7 millimeter glass substrates that are coated with conductive layers. There's some metal layers also involved to serve a good electrical conductivity, and this means also perfect uniformity in the application. And then you add a little bit of almost nothing in terms of organic materials on this, so it's very little material consuming, and then you end up with metallization. All this is done then in a high vacuum process, and to protect the device against the environment, you finish it with a thermal, with a encapsulation, thin film encapsulation, and in the end you have a thermal spreader and a mechanical interface based on a metal. So, if we look to the advances in OLED technology, so first of all, we've seen a massive, or our customers have seen a massive cost down, and we're able to meet the specifications for deep red. We have an unmatched uniformity. Please come to our booth. It's when you go through the main entrance here, directly on the left side. It's incredible, and even I, after working 20 years in OLED, I was overwhelmed when seeing the comparison between OLED and LED in the taillight. You are able to address individual segments, so you are able to do car-to-X communication, and on the following slides we will also see where it is going towards. It's, as explained, also very thin and ultra lightweight. And we see more and more car models coming to the market. So this is basically one example where you see where this is going to. You have seen OLEDs with larger segments. If you start to decrease the pixel size, you can increase the information content that your card can show. And if you then do the next step, you know where that's going to. It can basically act like a display, and by this you can add the signatures, welcome scenarios, and also do car-to-X communication easily. So let's look at the specifications of our OLEDs. So usually taillights running at 2000 nits, very deep red, lifetime at 60 degrees C. So for OLEDs in the past, there were a lot of discussions if they can make it. So we can provide you with more than 20,000 hours at 60 degrees C operational brightness. Storage 15 years, and also what's very nice is that you have the mirror finish in the off state. Okay, so for the OLEDs coming basically from the beginning of OLEDs, robustness was always a topic. When I started working on OLEDs 20 years ago, I was not thinking that this product can be this reliable, because basically we developed it so far. It passed all the automotive tortures, and even our customers, Dr. Kupper, involved into the development at that time, said that they have tested 3,500 hours at 85, and the product does not fail in the climate chamber. And I think the reliability is also that good. So here it's listed more than 5,000 hours. If you go on with testing, I think the probability that the climate chamber fails is meanwhile higher that the OLED product fails. Also testing low temperatures, high temperature storage, also thermal cycling to test different direction on different CDs of the components. Basically, everything is under control. So the OLED became mature and is ready for automotive applications. So this is basically showing what is available on the streets today. You can also see it, the demonstrator at our booth. Here for this Audi car model, there's 6 segments on the OLED. There's different welcome and leaving scenarios, and where this is basically going towards is increased pixelation, more options to display things. So this is basically the next generation. You can also see it at our booth. So the next steps for OLEDs in automotive basically is to get from the tail light also towards stoplight, gyms, turn indicators, and this is not like a breakthrough which is needed. It can be done with the existing technology based on stacking of the OLED devices. So we're using for the taillight something like this. It's basically 2 OLED stacks on top of each other because the aging is mainly current driven. So if you do that, you run this device at the same current. Of course, you pay that with doubling the voltage, but on the other hand, you also double the light output. And you can then triple, quadruple, or even 6-fold this with the same current, increase driving voltage, but the light output is also 6-fold and still has the same aging behavior. So we can achieve lifetimes for those high brightness applications very easily. So this is then an example of high segmentation. Basically, you see this can act as a display, and we're seeing today 10 or 60 or 100 segments, but this can also go up to 1,000 or more inside one panel. Here's an example on the different colors that we can do. So white is an option. You can also do the yellow for the turn indicator. We're not specific in terms of colors, sizes, and shapes. And we're prepared for also high volumes with high reliability and high quality, as we have state-of-the-art manufacturing lines available. The next step in this technology is, of course, to make it bendable, so that you can make it go around the curves in the car, especially in the rear end. You have this curvature, and the OLED has basically the potential to quite a lot decrease the size of your lighting element or lighting module, and if you can then also go around the curve, you can also realize this in this section. And the only thing, basically, what you have to do is you take the existing building blocks of the technology and you just replace the rigid glass substrate by a different substrate. In our case, we've chosen for also glass. By reduction of the thickness, glass becomes very flexible. So we're talking here about 0.1 millimeter thick glass. The only thing that you have to pay attention is that during the manufacturing steps, you don't damage it, you don't introduce flaws which would then later on potentially lead to a crack. So you have to work on the way how you manufacture that. Of course, you have to cut it down, you have to treat those cutting edges by some chamfering processes. But if you do that, you will also get a very high reliability, flexible product that comes along with the same reliability as the rigid products. And one example, this bendable demonstrator, you can also see at our booth. The specifications that we're targeting at is getting bending radius of 190 millimeter, which should be well sufficient for your applications. So, summary is, OLED lighting is now possible and affordable. You can use all those new features. It saves energy and materials, it's highly reliable, and Olledworks is basically the supplier you should talk to when you think about OLED lighting in your car. Thank you for your attention.